I'm Ben Lance, Executive Advisor to APC Media. That would include Power Systems Technology Magazine, Transformer Technology Magazine, and Women in Power Systems Magazine. We're here today in Paris, France at the CIGRE 2024 conference, talking with industry thought leaders, interviewing them to gain their insights into the trends, challenges, and solutions, and bringing those insights to you. So our next guest is Niclas Wetterstrand with Megger, and you are the industry director, global director for power systems protection. Is that correct?
Yeah, that's correct.
Right.
Yeah.
And well, we're here at CIGRE 2024, and well, from your perspective, what are you seeing as some of the industry challenges from power system protection?
Yeah, there are many challenges. I mean, electricity should solve the energy needs for the coming future, right? That's
right.
We go moving from fossil to electricity, renewable electricity. So there is a lot of things going on in the industry. And of course, with those initiatives, with the huge expansion that's expected, there are of course challenges.
Right.
So when you're growing something that rapidly, you need to do it cost effective, and you need to do it safe and secure and everything. Take all these aspects into account. So there are a lot of challenges, but that's the big perspective, I would say.
Sure. Anything in particular that Megger is working on to develop solutions to solve some of those challenges?
Yeah, of course, we are involved there. I mean, if you look from a bigger perspective, the energy flows in the network will probably change, since in the old design, if you put it that way, you had the large scale generation from one central position generating power through the network. So the direction of the power flow was downstream, so to speak. But now when connecting a lot of renewable power instead,
like distributed energy
exactly
resources.
Distributed energy,
right.
You do that on a medium voltage level instead, which means that the power can come from anywhere to anywhere. So to protect that network will be significantly different than in the past, both from the energy flow perspective,
right,
but also the magnitude, number of systems you have to install to cope for the coverage of these large scale to do it with smaller scales.
Right.
So there's a lot of challenges, and you have to do it cost effective due to that the larger scale. You cannot afford to spend a lot of money to do more. You need to spend less but do more. So it's kind of a challenge there in itself.
Right. So there are particular devices that Megger's developing to test that, or to. Yeah. So talk more about that.
Yeah, that's true. I mean, we are a test equipment company, so we make sure that the assets that are installed in general in the network work properly and are designed or set up to the proper protection, in my way then. And we of course have the equipment to check those protection schemes that they are working properly.
Okay.
Probably the network owners have to look into how they need to change to cope with this power flow changes.
Right.
And then what you need to do is to check again that you have done the right thing, so to speak, with simulations of the network,
right,
and how that power flow will do. And that's what our equipment do.
Wow. I know that I've heard of renewable energy sources being completely shut down. They'll have a fault, and then because the protection system wasn't set up properly, it takes the whole plant out.
Yeah.
So this could be substantial. And like you said, with all the complexity, with bidirectional flow and distributed energy resources, it sounds like it's going to be more of a challenge. We're going to need more testing technology to make sure it's right.
Yeah, I'm sure. Not only testing the different assets, I also anticipate that it comes more into system testing to test
the simulation
regions.
part?
Yes, it's simpler but also more complicated, I guess. So, but there are many things that we get into. So it's both that thoughts of those kind of testing with this more systematic testing. We are also into virtual testing to try to test things before
like
they are
simulation.
installed. Yeah, and see how the network would behave in such situation, which I haven't seen without having the assets there even. So
wow.
So that's kind
and
of
Megger
interesting.
is has technology to do simulations as well then, or?
Yeah, we do have. I mean, simulations, real world simulations
Real
is
world
what our products have done all the time. But
Okay.
now we can do it virtually as well.
Oh, tell
And
me
that's
more about
something we showcase here at the CIGRE.
right here at CIGRE.
Yeah, yeah.
Okay, tell me more about that.
So we have cooperated with Siemens in this case, where they have made a digital twin of their relay, and we have a digital twin our test set. So you can test those virtually together.
I see.
And then what you do when you see that everything works, then you expect that everything should work when you come to the reality. Then of course you have some hardwares and wiring that you need to check up when you come there. But the thought is that if you test the protection schemes and all those things up front, when you come to reality, it's only a few things that you have to check to make sure that the installation works. So it should save a lot of time and cost in the end by doing that.
I would even imagine with all of the challenges with the loss of the gray hair, the expertise in the industry, this is going to be even more important to have these simulations and to be able to send people to the field to check these complex systems. To have that integration is going to be important to build our workforce also.
Yeah, and also not only that, they can also train on the network.
Training, excellent.
In the beginning before doing anything, and there's no harm to send data signals across and the computer will not do anything. Whereas if you're out in the field and send high voltage, high currents, that could be dangerous both to the equipment but also to the humans. So this is a safe way to train the personnel as well, to get familiar with the network, and then when you're out there in the reality, you recognize what you've done, you can reuse your test files and so on and so forth. So that's just one of the things that we are showcasing here at CIGRE. So,
right.
Yeah.
Well, are there any other items you want to talk about as far as your showcase here?
Yeah, in particular, one thing, because something that becomes more and more common as a component in the industry is low power instrument transformers, which we need to simulate in a different way than what we have done with traditional instrument transformers. Those have much lower ratios of outputs, voltages, and currents. So we need to be more accurate in a very low range, which we haven't been before.
I see.
So we have cooperated with OEMs there again to find appropriate levels of accuracy and ranges. And so we have developed this completely new test equipment, which is a prototype here in this show, but we have a paper on that too.
Wow, excellent. A paper here at the conference.
Yeah,
excellent.
We presented that Monday on this conference.
But it'll be in the minutes if people want to look that up?
Absolutely, it's there. And also, like I said, we have a showcase in our booth, so I hope that many comes
And what
by.
booth number is that now?
That is S179.
S179. Okay, excellent, excellent. Well, any final concluding thoughts here to our interview?
No, it's a
want to share with our
pleasure.
readers?
A pleasure to be here, and thank you for this time. And I'm just happy to be in the industry right now because so much is going on, and we're really passionate about it to solve the problems of the world.
It is a good time to be in the power industry, isn't
Absolutely.
it? Niclas, it's been a pleasure.
Yeah, thank you so much.
Thank you for stopping by.
Yeah.